Hey guys, here's the review for Spiral 3. First off, we've got some right triangle trig. We've got triangles ABC, where C is a right angle in both cases. I'm going to start by drawing that. And if B is going to be 8, A is going to be 7. First thing I might do is the Pythagorean theorem to get that third side. And when I Pythagorize this, I get that C is going to be the square root of 113. The second thing I might do is to find one of these angles. I'm going to arbitrarily choose A, and I don't know, I'm in the mood for tangent. I've got the opposite and the adjacent. So I could say that tangent of A is equal to 7/8. Okay, that means that tangent inverse of 7/8 is going to be our angle. So if I do tangent inverse, making sure that I'm in degrees, 7 divided by 8, I get 41.185 degrees. And that means that B is going to be 90 minus that, or 48.814 degrees. For our second triangle, we've got A, B, C. A is going to be 7.1. A is 33 degrees as an angle. And let's say I want the adjacent side first. Or maybe angle B first. I don't know why I call that adjacent. Let's call that B. Angle B, just to get this out of the way, is going to be 90 minus 33, or 57 degrees. To figure out side B, I might use tangent and say that tangent of B is equal to little b over 7.1, or 7.1 times tangent of 57 is equal to B. And when I do the calculation, we get B is equal to 10.93. I could Pythagorize again if I wanted to, and in doing that I'm looking at 10.93 squared plus 7.1 squared, and whatever I get I take the square root of, and that's going to be really close to 13. Because when I take the square root of that, it's the square root of 169.9, and we get that C is equal to 13.036. And those are both right triangles. Finding the height of the tree below, we could do this using either law of sines or using some right triangle trig. I found that students tend to like the law of sines starting point, which is based on the idea that this is 180 degrees in total, so that part's 105. The first thing I might figure out would be this length here, which is the hypotenuse of the big triangle. And in doing that, what we can say is that sine of 105 over question mark is equal to, angle up top here is going to be 30 sine 30 over 20. Okay? And getting question mark by itself, I might multiply both sides by question mark and divide by the other stuff. We end up with sine of 105 times 20 over sine of 30. And when I do that out, being careful with my parentheses, I get that question mark is equal to 38.637 feet. Okay, now I've got a big triangle. I'm just going to draw it out here so it's a little bit easier to see. That's 45 degrees. This is 38.637. I'd like to know what that height is. This is going to be sine for opposite over hypotenuse. So sine 45 is equal to question mark over 38.637. And when I get that question mark by itself, we end up getting, the question mark is 27.32. It asks us the nearest foot. 27 would be our answer. If I wanted to do this with right triangle trig, I could set up a series of equations. And for this, I might have like an x there and maybe a y up here. And I might think about this as a small triangle and a big triangle. So I could say that tangent of 75 was equal to y over x. And for the big triangle, we're looking at tangent of 45 is equal to y over 20 plus x for that whole bottom part. I'm going to get y by itself in both cases, and that's going to make this look like tangent of 75, we'll do that as a decimal, 3.73x is equal to y. And on the bottom part, so tangent of 45 times 20 is just going to be 20. And tangent of 45 is 1, so it's actually going to be 20 plus x is equal to y. I want to get a number for y, so I'm actually going to substitute for x and do this as y over 3.73 is equal to x. So we get 20 plus y over 3.73 is equal to y. Bring the y's to one side. So it's going to be 1 minus 1 divided by 3.73. And we get 20 is equal to 0.732y. Divide by 0.732. 20 divided by that answer gives us 27.3. Either way is totally okay for you to do. Right now, law of sines is probably foremost in your head, but if you want to set this up as two right triangle trig equations, that would be fine. The blue stuff is right triangle trig. The red stuff is using law of sines. For number 3, we're looking at law of sines or cosines. I've got an SAS relationship here, therefore I've got to use law of cosines. And in setting this up, so we're trying to get b first, so we can use law of sines to get another angle. We end up with b squared is equal to 30 squared plus 16 squared minus 2 times 30 times 16 times cosine of 60. I can input that all, so we get 30 squared plus 16 squared minus 2 times 30 times 16 times cosine of 60. I get b squared is equal to 676. If I take the square root of both sides, that comes out to 26. Okay, now I might switch to law of sines to get another piece going on here. And I've got to be a little bit careful because I've only got an acute angle, and I've got 3 pieces going on here. So maybe I'll do the one that's 30 so I get the biggest angle next. So I might treat this as sine 60 over 26 is equal to sine A over 30. All right, multiply both sides by 30, and we get sine 60 divided by 26 times 30. And when we do that, I get really 1 is equal to sine of A. And it's 0.9, I think it's 0.9992. 9993. which gives me 8 is equal to 87.79 degrees. That's pretty good. That's really close to a value that makes sense. 30 is a little bit bigger than 26, and now 87 is a little bit bigger than 60 as far as angles. Let's get that third angle. I'm going to use law of sines for that third angle just to make sure it works out. You could also subtract from 180 and hope that it works out, but I trust law of sines a little bit more. Sine of c over 16 is equal to sine of 60 over 26. I'm going to multiply both sides by 16, and we get sine 60 divided by 26 times 16, and the inverse sine of that is going to be c is 32.2-ish degrees. And when I plug that in, we do add up to 180 overall, so we are okay. For number 4, we're given just the sides and angles. Let's make a possible triangle. So we've got 52, 22, let's call this B and this C, 26, and in this case we have an SSA triangle. Okay, I'm on warning. This is going to be law of sines, but definitely could have 2 answers here. And I'm not really sure if I do or do not. I know this gets a little bit worse because I've got the smaller side, which means I do need to account for both of those possible answers. So in looking at this, we're going to use 26 to find angle C, use that to find angle B, and use that to find side C, which is kind of a delightful problem, if I do say so myself. Let's take a look at how this might work. So if we've got sine of 52 over 22, and that's equal to sine of c over 26. Let's see what happens if I multiply both sides by 26. Sine of 52 divided by 22 times 26. We get sine c is equal to 0.9313. Okay, here's where I could go in 2 different directions. The first is normal, and that's if we're dealing with the acute version of this. And we get c is equal to 68.636. That means that angle B is equal to 180 minus that, minus 52, which is 59.3639 degrees. From here, I'm going to use the law of sines again to find side B. And I might take the original one, which is A, so 22 over sine 52 is equal to B over sine 59.363. 22 divided by sine of 52 times sine of 59.363. We end up with B is equal to 24.02. That's one option. The other option is if instead of 68.636, C is equal to 180 minus 68.636. Which when we do that, 180 minus 68.636, we get 111.364. Okay, and that means that angle B is going to be 180 minus 111.364 minus 52, which is 16.636 degrees. I'm going to do law of sines again. So 22 over sine 52 is equal to b over sine of 16.636. 22 divided by sine of 52 times sine of 16.636. We get b is equal to 7.992. Again, as soon as you notice that this is an SSA triangle, you have to at least try both methods. If at any point you get angles adding up to more than 180, or you get errors, you know that that side doesn't work and you might only have one triangle. But in this case, we had two that ended up working out. Find the area of the triangle for the previous problem. I could just take, I don't know, the pieces that we had. We talked about area can be described as 1/2 times a side times another side times the sine of the angle between them. And if I do that out, so we get 1/2 times 30 times 16 is 480 times sine of 60. We end up with area is equal to 207.846. As an alternative, you absolutely could have found that height and done 1/2 base times height. For the new stuff, we've got to do some sketching angles and dealing with radians. First part, sketching angle in standard position and finding two coterminal angles. Okay, negative 350. So we're going clockwise, not quite a full rotation around because 360 would be a full rotation. That's my angle. Coterminal angle 1 would be negative 350 plus 360, or 10 degrees. Coterminal angle 2 could be negative 350 minus 360, and that would be negative 710 degrees. Okay, for B, 660. So we're going positive. So there's 360. 360 plus 90 is 450. There's 540 plus another 90 is going to be 630. So another 30 degrees after that is going to be 660. Okay, 660 plus 360 is going to be 960, 1020. And 660 minus 360 is going to be 300 degrees. Those are two coterminal angles to 660. For number 6, find the measure of each angle. Well, in this case, you're given that. So the measure here is going to be negative 170 degrees. The reference angle is going to be the shortest distance to the x-axis in terms of the angle. And if that's 180 in total, the reference here would be 10 degrees. Number 7, converting from degrees to radians. I know that pi radians is equal to 180 degrees. I'm going to use this relationship to create a ratio, so negative 150 times pi over 180. My 10s cancel out. I've got negative 15 over 18 pi, which is going to be, I don't know why it's a negative. Because it was negative up there, negative 5 over 6, add my pi back in. Okay, number 8, converting from radians to degrees. That's going the other way. I'm going to divide by pi, and I'm going to multiply by 180. 180 divided by 6 is going to be 30. Pi's cancel out. 11 times 30 is going to be 330 degrees.